Hello, this is Mrs. Scarpel with the first of 3 planned videos for topic 1.7. In Unit 1B, we focus quite heavily on rational functions, which if you took Math 3 or an Algebra 2 course, you may be familiar with some of this, so hopefully it's not completely brand new. But if you do feel like it's not something you quite remember, that's okay. I'm here to help you get through this. So just a reminder of what a rational function is. A rational function is a function of the form f of x equals p of x over q of x, where p of x and q of x are polynomial functions, and q of x, the denominator, cannot equal 0. And hopefully that makes sense to you that we don't want the denominator to be 0 because any fraction, which is what a rational function looks like, it looks like a fraction with polynomials, cannot have 0 in the denominator or it becomes undefined. One of the simplest rational functions is the one in reciprocal form, or the reciprocal function, and that's f of x equals 1 over x. And as you can see, this is the shape of the graph 1 over x. In this video, I'm going to focus on vertical and horizontal asymptotes. In a later video, I'll talk about slant asymptotes, and yet another one will be about holes. So in this video, I just want to focus on the vertical and horizontal asymptotes. And an asymptote is a line which the graph approaches. So if you look at the graph to the right, you will see that it looks very similar to our reciprocal function. However, it is shifted. That shift has this vertical asymptote here. Let me put this in a color that'll show up a little better on your screen. So in red here, I'm marking the vertical asymptote, and that vertical line has an equation of x equals -3. And then it looks like both of these curves are approaching y equals 1. That is our horizontal asymptote. So it is possible for graphs to have these asymptotes, and you could very easily have pieces approaching them from two different sides or directions. So the other thing we're going to look at for today is how are we going to graph these, because this is going to be a big piece of the initial practice. So rewrite the function in factored form and simplify. You're going to find the x-intercepts by finding the zeros of px. Remember, any x-intercept has a y value of 0. So essentially, we are looking for what are the zeros in the numerator. Let me make that note instead. So we're looking for the zeros in the numerator. That will give you your x-intercept. The y-intercept by finding f of 0. So you're looking for what happens, or what are my values of y when I substitute x for 0. And you'll come up with most likely just one answer in this case. Vertical asymptotes are found by finding the zeros of q of x, or the zeros in the denominator. Running out of room. But we've got some special keys or some special things we need to remember when using or when finding horizontal asymptotes. When I say degree of P, I'm talking about the numerator. And when I say degree of Q, I'm talking about the denominator. So, if the degree of the numerator is greater than the degree of the denominator, we say there is no horizontal asymptote. So if you have a larger degree in your numerator than in your denominator, you have no horizontal asymptote. If the degree of P is less than the degree of Q, then the horizontal asymptote is the x-axis, which has the equation y equals 0. So when the numerator, the degree of the numerator is less than the degree of the denominator, our horizontal asymptote is going to be the x-axis. If the degree of both the numerator and the denominator are the same, if the degree is equal, numerator and denominator, then the horizontal asymptote is the ratio of the leading coefficients. And I'm talking about the coefficients of the numerator to the denominator. So ratio of the leading coefficients of the numerator and of the denominator. I will talk more about the wholes in my next video. So let's take a look at example 7. Example 7 has a lot of pieces to it. Because it has so many pieces to it, I want to take the time to take a look at this one. So first thing is I need to factor this in order to find any vertical or horizontal vertical asymptotes for sure, or my intercepts. However, before I do that, because I notice these have the same degree, let's go ahead and find our horizontal asymptote. The leading coefficient of the numerator is 4, and the leading coefficient of the denominator is 2. Remember, if they have the same degree, then your horizontal asymptote is going to be the ratio of their leading coefficients, and this reduces to 2. So I'm going to go ahead and just graph that horizontal asymptote. I'm just going to make it a dashed line across at y equals 2. So I have part of my graph figured out. Now let's take the time to do our factoring. I notice that the numerator is the difference of perfect square values. We can factor the difference of squares by using the square root of each term. So 4x squared, the square root of that is going to be 2x. So I have 2x in each factor. The square root of 9 is 3. One will have to be positive, the other will have to be negative. For the denominator, I notice that there's a common factor of 2. So I'm going to factor out that 2 just so I can see what's left. When I factor out the 2, I'm left with x squared minus 1. That is also a difference of squares. So my denominator has 2 times x plus 1 times x minus 1. Those are the square roots of the two terms in x squared minus 1. So let's start by finding x-intercepts. X-intercepts are going to be the zeros in the numerator. So, oops, I don't want to say x equals. I'm going to grab my eraser here quick. I'm going to label it x int just for space. So x-intercepts are going to be the zeros in the numerator. So if I set 2x plus 3 equal to 0, I would subtract 3 and divide by 2. So I have one x-intercept at negative 1.5. That's what negative 3 divided by 2 is. So negative 1.50 is one x-intercept. The other x-intercept, I'm going to add 3 and divide by 2. So that's going to be a positive 1.50. So I'm just going to go ahead, write them over here again, negative 1.50, 1.50. Those are my x-intercepts. So I'm going to place those on my graph. I know that my graph is going to intersect the x-axis at these 2 points. The y-intercept happens when we replace all those x's with 0. So for my y-intercept, I'm going to replace all of the x's with 0. So in my numerator, I'm going to be left with 3 times negative 3. My denominator, I'm going to have 2 times 1 times negative 1. If I replace all of these x's with zeros, I'm left with my constants and that 2 that was factored out. So this will simplify to negative 9 over negative 2, which is actually a positive 4.5. So my y-intercept is 0, 4.5. And let's go ahead and mark that on our graph. So here's 2, 3, 4.5. Now let's find vertical asymptotes. Vertical asymptotes are going to be the zeros in the denominator. So zeros in the denominator. So the 0 of x plus 1 is negative 1. So we're going to have one, I want to use another color here. We're going to have one at x equals negative 1. And we're going to have one at x equals 1. So I'm going to mark those on my graph as well. So at negative 1, we have a vertical asymptote. At positive 1, we have a vertical asymptote. And then I'm going to find just some points on either side to help me find what my curves are really going to look like. I know because I have vertical asymptotes that my x-intercepts are not going to be connected to my y-intercept at all because of this horizontal asymptote and because of the vertical asymptotes. Because they are asymptotes, the curves cannot cross them. I want to make sure though that my curve here is probably going to be going up. I'm going to do that just by testing a point. So I'm going to use 1/2. So if I plug in 1/2, I'm going to have 1 plus 3 times 1 minus 3 over 2 times 1.5 times negative 0.5. So my numerator would be 4 times negative 2, that's going to be a negative 8. My denominator, 3 times negative 0.5 would be negative 1.5. I'm going to end up with a positive value. 1.5 is going to go into 8. I want to say a little bit more than 5. So we're already at 4.5, so a little more than 5 would put us here. And because we have things that are being squared, if I put a negative 0.5 in here, I'm just going to end up with the same value on the other side. So my curve is ultimately going to look like this in between those vertical asymptotes. It's going to look something like this. Let me undo that last one. It looks a little rough. Here we go. So that's a sketch. Down here on the bottom, I'm fairly certain that I'm going to have it hugging or eventually getting close to both asymptotes. It's not actually going to cross like mine kind of looks there. We get close, but we don't ever really cross the values. If you want to find specific values, do like I did to find a point or find points here in the middle between the vertical asymptotes. Just create an XY table, plug in values of X, find your Y, and see where those points would be. But this is what this graph is going to end up looking like ultimately. We don't have any holes in this one. I'm not talking about holes at all in this video, and I purposely chose one of the examples that doesn't have holes. As far as domain is going to be all of those X values that we can use. Well, we have vertical asymptotes, so we have X values we cannot use. So our domain is going to be that X cannot equal -1, X cannot equal 1. For the range, we can use all Y values except where we have that horizontal asymptote. So my range is all Y except for Y equals 2. So Y cannot equal 2 is my range. If you have questions, make sure you ask. I'm always available to answer your questions. We will get lots more practice with this, especially when I add in the holes. That's just one added piece, but for the sake of the length of this video, I just wanted to cover vertical and horizontal asymptotes.